how do we analyze this? Can we reuse prior tools? Okay, some of the prior tools we know are KVL, KCL, okay, circuit theorems. All of them we know, right? The answer is yes for all of them. Okay, if we start using something called phasors. So if you were, what is given here as sinusoid, if you convert that into what is known as a phasor, notice this coordinate transformation, we have been talking about it since we started our math class, right? Any hard problem here, we always look for transformation that will make our life easy, right? One such transformation here is conversion to a phasor, and here the problem is very, very easy. Okay, and this is known as a time domain representation. Things are functions of time. Okay, and this representation here is known as frequency domain. And the moment you are dealing with phasors, the answer to, you can start using all the tools that we already learned. That's what makes our life easy. So we have to learn this one tool. Okay, again, to help everyone, let's start with basics. Let's understand what a sinusoid is. Then let's go how to convert that into a phasor. Then let's understand phasors, and then let's start applying phasors. Sinusoids, we have a couple of things. Okay, I need concise answers from everyone. We have T, okay, F, then we also have omega, right? There is something called time period. What is a time period? Can we have a concise explanation? Or if you want to, give an analogy between heartbeat, heart rate, length of heart, heartbeat, that would also be good. But what is the time period? Time period is like a length of a heartbeat. Yeah, this is time to complete one cycle. That's a nice, concise explanation. Period after which wave repeats itself, is time period. Of course, to be slightly specific, in the minimum period, f of, t plus t, you think you have progressed after 1 month, but all of a sudden you forget it. You only know what you learned last month, right? So, things, signs, the sign goes up and down, right? Wavy. So it starts is it's some value, it reaches its peak here, it goes down, gets back to its peak. Okay, that is known as the time period. Okay, notice it's the shortest cycle. And then the question here is, sir, 0 becomes 0 here. So shortest cycle is t by 2. No. It should actually apply for every value in the curve. So not 0. 0 is a specific case. We want it for every function value. That is the minimum value that satisfies is t. Okay. And this is like length of a heartbeat. Now, what is frequency? Yeah, we want to understand, how many times it kind of, how many peaks in 1 second. Sometimes they are kind of interested in that. Okay, so the longer the time period is, the smaller the frequency is. So there is an inverse relationship. The proportionality constant is also actually 1 here. Okay, this is like heart rate. Okay, number of cycles per second, number of repetitions per second. I suppose all of you kind of agree with it. And we have this thing called angular frequency. Okay, yeah, number of oscillations per second, number of oscillations number of cycles per second, number of oscillations per second, right? Per second. Now we have angular frequency. This is essentially, the speed of this oscillation or speed of this cycle. How do you know that? Notice in the curve shown here, it goes 2 pi radians in t seconds, right? 2 pi radians in t seconds. So its angular speed is 2 pi by t, distance by time, right? Angular frequency is, again, this is in radians per second. And you could notice that if you use 1 over t as f, this is 2 pi f. Okay, and we have frequency, and then we have angular frequency. And if there are any doubts, angular frequency, again, this is in rats per second. They ask you for frequency, NAT type question, and the units are in rates per second. They are actually referring to angular frequency, right? So notice the units used here. Okay, again, let's understand. Notice sinusoids also has something called a phase. We have seen lots of Desmos videos here and there. We take a function f of t. Okay, if we do f of t plus a, the function is going to shift backwards, right? If the first original function is a sine, okay, it has a peak value of Vm, and its time period is t. Okay, there is some question on how do you know when angle given is in degree or in radians? Omega is always expressed in radians per second. Okay, and phase typically by convention is, whatever we are seeing here is expressed in degrees. Okay, I'll come to that in a moment, but notice, so this particular curve, uh, Vm sine omega t, we already know omega is 2 pi by t. When t is t, essentially we have 2 pi, right? So that we know. So one time period here is exactly 2 pi. Okay. So given the sinusoidal function, can you first confirm t equals 2 pi? How do you quickly confirm that? Yeah, and also notice this axis in omega t. So essentially, when omega t equals 2 pi, the thing actually repeats. Okay. So this is not time axis. This is somewhat of a scale time axis. So whenever omega t value is 2 pi, if you start at 0, you get back at 0. That's how to make sense out of this x-axis here. That's our first function. We are not going to deal with sinusoids that always start at 0. We are going to deal with sinusoids that start at some non-zero value, negative, positive. It can start anywhere, okay, here, between the two peaks. That means the curve corresponding to that, if it is started here, slightly, the less than the peak, the curve kind of has a 0 over here. And we know the relation between these two is, take the first function, have a delay, or advance the first function by shifting it with a plus phi. And this phi is known as a phase. Okay. Notice when you take derivatives and all that, only omega matters. Phase doesn't matter. Phase is a constant, right? And by convention, omega is in rad per second. Okay. Phase expressed as as a angle. Okay, it's expressed as angle. So if you want to actually calculate that the value, you'll have to convert the angle to radians, and this is radian, this is radian. You can add and then convert. Expressed as an angle. Okay, this for simplicity, this convention, and it's easier to read what the angle is. It's 90 degrees. It's say 30 degrees, 40 degrees, and all that.